Hello there, how are you? This is a new video that I'm recording for you, and this video is about automated systems and emerging technologies. Okay, automating and emerging technologies, chapter number 6. Let me put it in this way. I want to do it like this. So, automated systems are widely used in manufacturing, home automation, healthcare, robotics to monitor environments, make decisions, and take actions without human intervention. These systems rely on sensors, microprocessors, and actuators working together. Okay, let me try to explain you what is this in a way that maybe you are going to understand. Um, have you ever go to Ballowing? Oh, how do you write this? Okay, I forgot how to write it, but it's a game in which you have something like this. Yep. And you have many of them. You have 10 of them, and you are going to, with a ball like this, you are going to throw it, and you need to put all those pins down. Let me show you something to try to explain you this. Okay, there is not a good example here, but let me use this image, okay? This is ballowing, okay? So you are going to use these little balls to put those pins down. What happened when you put them, all of them down, or some of them down? So you need to go and put them up and organize them again. So you have to do this manually. Today, in Ballowing, they have a system that detects the pins that you put down, and in an automatic way, the systems put all the pins back again to continue playing. So that means when here you read that you do something or the system does something without a human intervention. Okay, that is automated systems that use sensors, microprocessors, and actuators. Okay, so the key components of an automated system: input devices. So let me start giving you. This is the reason that these videos are too long, because I use a lot of examples here. So let's suppose that here you have in your ballowing, so you have the pin, for example, and this is the one that you are going to put down with this ball. And here in the in this part, they have a kind of sensor. Obviously, if you have 10 pins, obviously they are going to have 10 sensors. One sensor per object that you are going to have. When you put down this, so that means that the sensor is sending a signal. That signal is interrupted by this object. That means for the sensor that there is an object there. When you send the ball and this object is not there, so the sensor continues sends the signals, and there is not any information getting back. That means that there is no object there. So that means that this object is not in the place. Okay, so this is just talking about valuing. Let's talk about a system in which, for example, you are going to get it get in inside a market, and here in this part you have the store has a sensor that is always sending signals, and when you step in front the door, what happens with the door? The doors starts wide open, starts opening. Okay, that is an automated system. Um, I have a lot of examples for you, and you have a lot of examples there. So the first component is the sensor because it's the input device. That means that the sensor is going to detect physical changes in the environment. That signal is going to be converted to digital signal or into electrical signal. Okay? Okie dokie. Next one. Examples of sensors. There you have temperature sensor, pressure sensor, light sensor, infrared sensor, proximity sensor, gas sensor, and you have the purpose there. Okay, so you obviously you are going to have this presentation, so you are going to be able to read it. You have the sensor and the purpose of each sensor. Okay, next one. How does it work? For example, a temperature sensor detects high heat. So that means that el calor empieza a subir. High heat, okay? So the sensor sends an electrical signal to a microprocessor. Then the microprocessor processes the data and decides whether to activate a cooling system. One give you an example. Let's suppose that here we have a temperature sensor. So here I'm going to work temperature sensor. Sensor. Ah, es sensor. Sensor. Okay. If the heat increases, the sensor sends that information to a microprocessor. The microprocessor starts checking some rules that we have. And let's suppose that if the temperature exceeds the 24 Celsius, so the microprocessor is going to send a signal to the cooler to refresh the environment. Okay? Okie dokie. Let's continue. So, the microprocessor is the brain. It's a small CPU, a central processing unit that processes the information that receives from the sensor and makes decisions. Okay? So, I already explained how does it work. The actuators, in this case, our actuator is the cooler. So when the cooler receives the information from the microprocessor, the cooler start sending fresh air that the heat starts going down. Okay. Now, types types of actuators. Electric motor produces rotational movement. Solenoid creates linear motions. For example, when the door opens and the door closes. Relay switches circuits that, for example, turns the lights on, turns the lights off, and a servo motor that moves, that has a control for movement. Look at here. For example, if you have an electric motor, you have, for example, this one that is going to move in this way always. But if you have a servo motor, do you remember that we used a servo motor the previous year? And this servo motor has something like this. And this one moves here or moves here. Okay? That is just the movement of the servo motor. Next one, how does it work? I already explained. The sensor receives information from the sensor. The microprocessor process the information, makes a decision, sends a signal to the actuator, okay, to act, to execute a specific activity. How sensors, microprocessors, and actuators work together? I already explained. You always are going to receive input information by the sensor. You always are going to analyze information by the microprocessor. You are going to take a decision by the microprocessor, analyzing the information and comparing the information with the rules. And according with the rules, is going to make a decision. Then, when take a decision, sends a signal to the actuator to start a specific activity. Okay, so this is the summary table. And okay, so advantages and disadvantages of automated system in different scenarios. Okay, for example, for industry, manufacturing and production. Example, robotic arms in car factories. Okay, so let me show you here faster. Car factories. So this one, robotic arms in car factories. Okay, so let's continue here. Robots assemble vehicles faster and more precisely than humans. Advantages, increased productions. For example, if you use humans, let's suppose that in one day you are going to assemble 10 cars. Using an automated system, you are going to assemble 1,000 cars a day. Okay, reduces human error and improves product quality. Works 24 hours, 7 days of the week without breaks, and reduces workplace injuries. Okay. Disadvantages, high initial cost. Can you imagine how much this costs to implement? Too much. Job lossless. That means that, for example, here, these people that is working here is going to lose their jobs because the robotics. Okay. Okay, okay. Okay, okay. And system requires regular maintenance and updates. Okay. Next one. Transport. For transport, we have the self-driving cars and traffic control. For example, the autonomous vehicles, self-driving cars. Those use sensors, use artificial intelligence and microprocessors to navigate on roads. Okay. Advantages: reduce accidents caused by human error, optimize fuel consumptions in traffic flow, and increase accessibility for elderly and disabled people. What that means, for example, if you are, let's suppose that you don't have legs, but you have a self-driving car, so you can use your car to go from your home to the school, for example, and nobody is taking you there. It's just your car. Disadvantages: it's an expensive technology. You possibly may have hacking risk and legal and ethical uses. Okay, what happens if an accident happens? Who is going to be responsible of this? Okay, now agriculture, automated irrigation, and drones for farming. Okay, you have a mock, you were assessed with this one, automated irrigations. So the advantages, okay, the sensor is going to measure the moisture in a determined field. Okay, when the mixture is not the necessary for the ground, so the system is going to start putting water on your plants or your ground or wherever you put your automated irrigation system. Advantages: save water. Advantages: increase crop yield with precise watering. So that means that you are going to put the appropriate amount of water. Reduces labor cost. Disadvantages: is expensive to install and to maintain. Requires stable internet and electricity. And over reliance on automation may lead to lack of manual skills in farming. 15. Weather. Automated weather stations for meteorological stations. Use temperature, humidity, and pressure sensors to provide accurate weather forecast. Advantages: more accurate and faster weather predictions. For example, el IDEAM. Let me put here IDEAM Clima uses technology to know or to predict if the weather is going to be, for example, a sunny day, a cloudy day, or a rainy day. Okay. Helps in disasters preparedness and work in remote areas without human intervention. Disadvantages: maybe the sensors, you are going to have sensors failures, is expensive to maintain, and is limited to human judgment. Let's suppose that we as human read wrongly the information, and let's suppose that we're going to say today is going to be a sunny day, and you don't take your paraguas your to the school, and it start raining and raining and raining, and you get wet. Okay. For gaming, artificial intelligence and motion sensors. Let me try to explain this. Um, Let me show you here. There are some games. Okay, this is a video that I recently uploaded for you. And let me I'm going to put something like this. Okay. I'm gonna put ATS gameplay. Okay, dokie. This is a game. I am not going to put the audio, and I hope that YouTube doesn't mute my video for this one. Here, here, no, here. Okay, these cars that you are seeing here, this one is driving, is it's been driving by a person, obviously in the game. And these cars use AA to recognize when a red light, you must start for a red light. For example, let me see if this person crashes. Okay, in this game, the traffic is used artificial intelligence. Okay, that is the reason that here for gaming use artificial intelligence and motion sensors in video games. That means that, for example, if you start getting closer to those cars is going to start stopping, or if you crash one car, the that car stops. Okay, so artificial intelligence in gaming. So advantages: provide realistic and immersive experiences, improves physical activity in gaming. For example, gaming is about fitness, adapts to player skills levels using artificial intelligence. Disadvantages: you need expensive hardware. For example, the VR headsets, motion sensors, not always accurate. So Possibly the sensor is not going to be getting the right information at the moment, and health risk such as motion sickness and eye strain. Lighting, science, and here you have a summary table. I am not going to speak about everyone because the idea in this video is to be short. Okay, so let's continue the slide number 20. Robotics. What is robotics? Robotics is a branch of a computer science and engineering that focuses on the design, construction, and operation of robots. Okay, robots are automated machines that can sense, process, and act based on programmed instructions. The key components of robots. A typical robot consists of sensors, obviously, to detect the environment, microprocessor and controllers to process the information and make decisions, actuators to perform physical actions, and power source, obviously, because you need energy to put your robot on. Okay. Examples of robotics in real life, factory equipment. I already showed you about the car factory. Advantages, high precision, 24/7 days operations, reduce human risk. Disadvantages, high cost and job displacement. Domestic robots, robots designed for household tasks like vacuum cleaners, AA assistants, along moving robots. Advantages, save time and effort, improves home convenience. Disadvantages, is too expensive and potential security risk. Drones used in military surveillance delivery services, for example, Amazon drones, photography, and more. Advantages, can operate in dangerous areas. Disadvantages, privacy concerns, and potential hacking risk. Robots is programmable. So that means that you are going to program the robot to do whatever you want to do. Okay? Now, if you have a robot, your robot to be classified as robot needs to follow in these characteristics. Needs to have a mechanical structure or framework. What is that? Let me show you. Obviously, I like using images here. Chin, chin. Mechanical structure. Um, Let me show you. Not in this way. Listo. Mechanical structure. This one is this something physical. Okay. So every robot has physical structure that allows it to function in its environment. Example, I already showed you one. Next one, electrical components like sensors, microprocessor, and actuators. Okay, okie dokie. Must be programmable. That means that a robot must be programmable, meaning that it follows a set of instructions, algorithms to perform tasks. The programming can be done using software, artificial intelligence, or predefined scripts. Okay, so if you need to know if a robot is a robot, needs to have a mechanical structure, electrical components like sensor, microprocessor, and actuators, and must be programmable. Okay, next one, roles of robots, advantages or disadvantages. So you could use robots in industry. The role is that is going to use to assemble lines or assemble things. Okay, for example, what I show you here, assemble cars in this example. Advantages, work faster, reduce human labor costs, can operate 24/7. Disadvantages, high cost, job lossless, and require skilled workers for programming and maintenance. Transport, okay? I think in previous slides, I wrote something pretty similar, okay? So, robots used in transport, autonomous vehicles, and drones. Agriculture, I already explained that. For example, for farming or irrigation system, for medicine, surgical and healthcare robots. So, for example, the role assist in minimal invasive surgeries, robotics arm in surgeries, use in rehabilitations, elderly care, and diagnostics, and medical robot dispense medication and help in patient monitoring. Advantages, high precisions, reduces recovery times, can assist in areas with a shortage of doctors. Disadvantages, very expensive technology. Malfunctions can have life-threatening consequences. Imagine that you are getting a surgery and the robot that is assisting your doctor fails. Oh man, I cannot imagine what happened there. And reduces human interaction in patients' care. Domestics, we already talked about it. Here we have, for example, Alexa, Google Home, your bot for cleaning, vacuum cleaning. Oh, you know more than me about that. Entertainment, we already talked about it. And here you have the summary of roles of robots. Okay. Artificial intelligence. What is this? It's a branch of computer science that focuses in creating machines and software that can simulate human intelligence. AI systems are designed to analyze data, learn from patterns, make decisions, and solve problems. Okay? Characteristics, learning. A normal robot, the robots that we just talked about, you have your physical part, your electrical part, and is programmable. But that programming is just for doing a specific task. But a robot with artificial intelligence can learn about experiences, has reasoning. That means that that robot with artificial intelligence can analyze situations and make logical decisions. Problem solving. The artificial intelligence can identify solutions to complex problems. Perceptions can process images, sounds, and languages. Interactions can communicate with users. How artificial intelligence works. Basic process. As always, you need an input that you always need to send data to the software, to the IA, artificial intelligence, whatever you are going to use, always needs or always starts with input data. Could be text, images, speech, or sensor readings. Obviously, that information must be analyzed. Decision making. The artificial intelligence generates an output based on patterns and logic. Learning. Artificial intelligence improves over time using new data. I'm going to give you an example. Let's suppose that a robot you bought a robot and you put your robot in your apartment and you put the robot to recognize the place you live. So the robot is going to identify, okay, here is a wall, here is a door. So it's going to recognize your place and it's going to learn how to move across your apartment. Let's suppose that you may say, okay, but The robot scans everything and all the information is stored in a database. Yes, yes, that could be true. Okay. But what if you put a new object in your house? With the sensors, the robot is going to identify the new object and is going to say, okay, I'm going to update my database and now I cannot cross over there. Why? Because there is something new there. So the artificial intelligence improves over the time using new information that is called machine learning. And output, artificial intelligence provides responses, predictions, or actions. Okay, there you have an example. A self-driving car takes a sensor data input, analyze the traffic conditions, processing, decides whether to stop or accelerate decision making, and improves its driving over time. Learning. Application of artificial intelligence, healthcare for diagnosis diseases, robotic surgery, finance, fraud detection, stock market predictions. For example, this one, if you use artificial intelligence here, getting some patterns, a robot or with artificial intelligence is going to predict if the price here, the price over here, let's suppose that we are going something like this, teen is moving like this, is teen like that, dun, and okay, is going to make a decision with the information that we have here. Let me show you. There is a lot of time without using this. Okay, here is an information, is going to read information, and is going to decide, and is going to say, okay, this means that this is going to go up. So please buy. Or is going to continue goes down. So please sell. Okay. So it's going to be able to predict in finance. Automotive, self-driving cars, educations, personalized learning, automated grading, security, facial recognition, cybersecurity systems, entertainment, artificial intelligence, generated music, gaming, retail, chatbots, recommendation systems, like for example Netflix and Amazon, that they base on the activities that you do and start suggesting movies or series for you. That Amazon and Netflix do it using artificial intelligence. It's not just about a database, it's more than that. Okay. And here we have here, what is, oh, I think, what is the, if I lost the numbering here. Okay, here. Characteristic of artificial intelligence. The ability to reasoning, to reason. So artificial intelligence is going to analyze the data and apply logic to make decisions. Okay. Learning and adaptation. So I told you, I gave you an example that you bought a robot and the robot scans all your department and know the places that the robot can move. Now you put a new object. Now the robot recognize a new object, so it's going to make the decision that okay, in this way, I cannot go in because there is a new object there and I can move there. Okay. Summary. Always you are going to have okay, data collection and rules. I think I missed that slide. Yes. Okay, sorry. The first characteristic of artificial intelligence is data collection and rules. So all the information is going to get inside the system, is going to be processed and compared with the rules. Then the information, with that information, the artificial intelligence is going to make a logical decision based on data and is going to improve all the performance over time. Now, intelligence systems simulate intelligent behavior by using something that is called expert system and machine learning. So, what is an expert system? An expert system is a computer program that mimics human decision making by applying a set of rules to a knowledge base. Is commonly used in medical diagnosis, fault detection, and legal advisory system. Components in a in an expert system. Entire. I'm sorry. Okay, the components. Base of knowledge. That means a database of facts and expert knowledge. Es una base de datos con hechos y con conocimiento de expertos. Sample, medical hypnosis and diseases. Rule base, a set of if-then rules to process the knowledge base. So remember, I want to give you an example here. Let's suppose that you are going to install a system in your house. Let's suppose that you put your clothes after you wash your clothes. You don't have a secadora, but you are going to put in the backyard of your house the clothes to be get dry. But it start raining, so you have a system that detects if it's raining. If that is true, then you are going to make that your system move your clothes inside your house, and that means that your clothes is not going to get wet. Okay, so that means that set of if something is true, then do this. If something is true, then do this. Okay. Engine, the thinking part of the system, it applies rules to the knowledge base to deduce new facts. Okay. So that means that according with some facts, de acuerdo con los hechos, okay, o las cosas que van pasando, puede deducir nuevos hechos. Okay. And user interface allows user to interact with the system and receive advice. Okay. Okay. An example: medical expert system diagnoses illness based on symptoms entered by a doctor. Let me give you an example. What do you feel today? Okay, I have I don't know, cough. I have throat ache. I have okay, and the doctor is going to put everything in a system, and the system is going to say your patient, your client has flu. Yeah, just putting information inside the system. Careful diagnosis systems. So, for example, you take your car to your mechanic, and the mechanic start scanning your computer, detecting fails, and is going to compare those fails with a database. So it's going to say, okay, es que la chumacera está rota, whatever. Okay, yeah, but it's going to be done with information that is going to be read it in this case. Okay, another one, machine learning. Let me. What is happening? Okay, machine learning. point number two here. Machine learning. Machine learning is an artificial intelligence system that can learn from data and improve its accuracy over time without human intervention. Okay, that means that is something like you. Let's suppose that you are going to go to a dangerous street and you get stalled in that street. The next day you get to the same place and you decide, okay, yesterday I was stalled in this street. That means that today I am not going to take this way. I'm going to take another way. That is learning. You are going to learn using information. You are going to learn um, about patterns. You are going to learn about the consequences of your previous decisions, and you are going to start changing your decisions. But let's read it here. Okay, traditional programming. Humans write explicit rules for computers. So you are programming the computer. Machine learning. The system identifies patterns in data and adjusts itself automatically. I can't pronounce that word. What that means? Si yo identifico cierto tipo de patrones, a ver. Ay, un juego fácil. Cuando ustedes, ay no, pero yo nunca he visto que jueguen eso en el colegio. Let's suppose that you are going to jump, saltar lazo. Okay. So a couple of persons are moving the lasso and start moving it faster. And you are going to enter to start jumping with the lasso in movement. So you need to identify how fast that cord is moving to decide in which moment are you going to get inside and start jumping. So you identify some patterns and adjust the way that you are going to get in the game. Okay. Now, how machine learning works? Training. Okay. So the artificial intelligence is given a large data set to analyze. So it's going to analyze a lot of information. It's going to recognize patterns. Okay. And is going to start making decisions according with the information that has learned. Okay. And improvement, that means that is going to adjust process. Okay. That means that possibly the second time that you are going to start going inside that game, you are going to do it a little bit faster because you recognize the pattern of the last one. Okay. Examples: spam filters. Learn to detect spam emails by analyzing previous messages. Voice assistants. Improve speech recognitions based on user interactions. Have you used Alexa or Siri? If you notice at the beginning, that assistant doesn't recognize all your words at the beginning. And when you start talking with Siri or with Alexa, that recognize your speech and start improving the understanding of your comments. Okay. And self-driving cars learn how to recognize road signs and obstacles. Okay. This is a summary about artificial intelligence systems. So remember, in artificial intelligence systems, you have expert system and machine learning. The expert system use a knowledge to simulate human making decisions. And the machine learning learns from the data and adapts itself without human intervention. Okay? So guys, I hope you can understand this new video. And guys, this is the last video about this. The next video are going to be about programming and logic and databases. So let's see in another video. Bye bye.